In this class, we will study about drift velocity. Now, we know if you take an E metal, the metals have a large number of free electrons. In metals, there are a large number of free electrons. Free electrons. And these electrons move randomly. If you take a metal, there are large number of free electrons, and these free electrons move randomly. But when you apply an electric field, if you apply an electric field E to this metal, then what happens is the free moving electrons, so all these free moving electrons will gain some acceleration. So that acceleration is given by, we know acceleration is forces mass into acceleration, so that will be the electric field applied, force divided by mass. So if force is given by electric field applied multiplied by E divided by mass of electron. So the electron experiences an acceleration in the absence of an electric field. But this acceleration is momentary, because what happens is the electrons, when start moving, they collide each other. So while moving, they collide each other and they lose this gained velocity. Due to this collision, the electrons lose the gained kinetic energy, and hence we can say that this acceleration is momentary. Because of collision, they lose the gained velocity. So an average velocity which the electrons can gain, we call it as drift velocity. So we'll write the definition of drift velocity. What happens in the absence of electric field? The electrons move very randomly. But when you apply an electric field, the electrons gain some acceleration. But this acceleration is momentary, because when the electrons move each other, they collide with each other, or the gain due to collision with vibrating atoms or ions or other free electrons. So they lose this gained velocity, but the average velocity which the electrons can gain in the presence of electric field is known as drift velocity. The average velocity of the electrons gained against the electric field. The average velocity of the electrons gained against electric field is called drift velocity. Called drift velocity. And drift velocity is generally represented by V suffix d. So drift velocity is denoted by small v suffix d. Now we will define another term called relaxation time. Relaxation time. And it is denoted by tau. The relaxation time is denoted by tau. So this is the average time between two successive collision. Average time between two successive collision. two successive collision is called the relaxation time, and it is denoted by 2. Average time between two, not this 2, it is 2, between two successive TW, what should be. So here average time between two successive collision is called the relaxation time. Now the force on electrons when we apply an electric field is given by, so if E is the electric field applied electric field, the force on each electron is given by force on electrons. Force on electrons F is E into E. The acceleration gained by the electrons, is given by A is force divided by mass of electrons, so I can write it as E into E divided by m into small e, where m small e is the mass of electrons. So the drift velocity is given by the drift velocity Vd so we know velocity is A into 2. So A is E into E divided by me into relaxation time. So this is the drift velocity, acceleration multiplied by time, E into E divided by me into 2. 2 is the relaxation time. Next we will see the relation between drift velocity and electric current. Relation between drift velocity and electric current. So relation between drift velocity and electric current. Now consider a conducting wire of length L. So we will consider a conducting wire of length some capital L. So this is a wire. So let the length of the wire is capital L and it has uniform cross sectional area E. So let us say in this an electric field capital E is present. So due to the electric field E, the electrons gain acceleration and they move with velocity Vd, that is called drift velocity. So let me say this is the drift velocity Vd. So let us say an electric field E is present in this conductor. We'll write what are the things? So L is the length of the conductor. Consider a conducting wire of length L. Length of the conductor. A is the area of cross section. Let small n is the number of free electrons per unit volume. Let this conductor has n is small n is the number of electrons per volume, per unit volume. So the total number of electrons is obtained by n into multiplied by the volume of conductor. Now let us say E is the applied electric field. So the distance, this Vd is the drift velocity. So we can write Vd, which is equal to drift velocity. Drift velocity. Now during the time delta t, the distance traveled is given by due to this electric field E, the electrons gain some acceleration and they move with drift velocity Vd. So how much is the distance traveled during time delta t? The distance traveled during time delta t is given by during time delta t. The distance traveled during time delta t is velocity. The distance is given by velocity multiplied by time. Let us say this distance is somewhere here, so this much distance it travels during time delta t, that is V into delta t. Now how much is the number of electrons in this portion? So in this portion means during this length, within this length, what is the number of electrons present in the conductor? Number of electrons in this portion is equal to, we know n is the number of electrons per volume, so it will be n multiplied by volume. So that will be equal to n multiplied by the volume. So this is the distance multiplied by area, length multiplied by area will give you the volume. So we can write the volume as Vd into delta t into area. This is the number of electrons in this portion. Now charge crossing the area in time delta t is charge crossing this area in delta T is in time delta T is delta Q equal to, so number of electrons multiplied by the charge of each electron. So the charge of each electron is E, so it will be E multiplied by number of electrons, that is N into Vd delta T into A, because the charge crossing the area is given by charge of one electron multiplied by number of electrons. Therefore electric current I is given by current I is delta Q by delta T. Delta Q by delta T, which is equal to delta Q is E N Vd into delta T into A divided by delta T. So here delta T will get cancelled, and this will be equal to En A into Vd. So this is the relation between the drift velocity and current I. So I is written as N into E into A into Vd. So this is the relation between the electric current and the velocity Vd. I is N into E into A into Vd. NEAV. The current density is given by, if you want to find out the current density, that also you can find out. J is I by A. So which will give you from this equation, substitute the values, you will get N into E into Vd, because A and A will get cancels. The current density and the drift velocity is given by J is NEVAD, where J is the current density. J is the current density. Remember, the current density is given by current by area, NEVD.